And we are, wait a minute, there, we are recording. All right, so here's a good example of a close selection is a good example of a, I guess you want to call it a margin of error, and how a margin of error is, hold on a second, how a margin of error is used to make a confidence interval. And to vote for Smith, and she needs a majority, more than 50%, to win without a runoff. The margin of error is 3%, 0.03, and 0.52. Will she win? So the first thing you do is you're adding 0.03 to the right, and you're subtracting 0.03 to the left. And 49 to 55. So technically, she's not going to win because she has to get 50%, and one side is 49%. So by reading the question the way it's reading, she needs a majority. Right here, she's not getting a majority. You to write that problem down, not because I will test you on it. I don't think I have a question on the test like this, but this is a standardized test question. So if you're going to take a standardized test in the future, this kind of question will be on there. And that's it. You take 0.03. Now, the reason I use decimals is because most of the time when you have a percentage, you change it into a decimal. So they didn't do that. I disagree with a lot of stuff this 103 book does, and that's one of the things I disagree with, because in probability and statistics, you would not be using percentages, you would use decimals. Okay? Any questions on that? Y'all wouldn't ask them if you did. I think y'all would sit there and have a question. I don't have an X. This thing is acting weird. I'm sorry. There we go. Nope. 5. Somebody check. Do we go into 5C next? I believe we do, correct? Somebody got their outline in front of them?
Yes, sir.
Is it 5C?
Yes, sir.
Thank you. You're the one that printed out your. See, look, it's doing some weird stuff this morning. That's blank. Not supposed to be blank. I have no X up here, so I'm having to go from memory. And it's, of course, they haven't got this room right. They haven't got it right. They put in new, and they haven't got the settings right on it, and they wonder why I want to teach from home. Okay. Y'all just gonna have to hold on a minute. Something's not right. Five C. Okay, I'm supposed to. What's going on? Something's not right. Okay, frequency table. Write that down, a frequency table, and it's kind of hard for me to do this without my whiteboard. Dadgummit. Let me see if I can pull up the whiteboard. I'll see if I can. We've been playing trying to get it to work this morning. I can do it with my mouse, but the problem is I can't write with my mouse. I can draw with my mouse. I don't know if any of you ever tried to write with a mouse, but it's not very easy to do. Of course, some of y'all invented the mouse. So frequency table consists of, on this side, I'm going to just use the text. Brunettes, and redheads. This isn't going to work. I don't think I'm going to be able to do this. I'm trying. There we go. Blondes, brunettes, and redheads. And then on the right-hand side, you'll have your head count. But of course, head count is not sophisticated enough. Does anybody know what the right side of your frequency distribution is called? Anybody? Anybody that wants to interact with me today? Okay. It's called frequency. A frequency. Can't call it a head count because that's too redneck. So you have to call it a frequency. It's always nice to interact, especially with a class. Blondes, brunettes, and redheads. And then on this side, I wish this stupid thing would quit popping up, but I'm sorry. 15, 25, and 3. That is a frequency distribution. Well, anyway. Nothing. Thank you, class. All right, next. Over here, we've got ages. And over here, we got head count or frequency. You got to talk fancy when you say frequency. And hold your pinky up. Like Patrick says, Patrick Starr, putting on airs. Yeah, I remember that episode, Hubert. Good. I knew we'd have some SpongeBob fans in here. Y'all settle down, please. All right. So over here, we're going to have 21 to 24, 25 to 29, 30 to 34, 35 to 39. And here, we're going to have 5, 10, 15, and 3. Now, the reason I took all that time to do this is because I'm going to ask you a question about these two frequency distributions on a test or a homework problem. And I bet I cannot, let me do this. Does anybody know what question I'm going to ask? Anybody? I'm going to ask you, what's the difference between the two frequency distributions? That means I want y'all to interact with me. So Miss Oglesby and Mr. Cone, you know, those people that aren't weaned on a pickle, what's the difference between these two frequency distributions?
One is showing age and the other is showing something that everybody has. Like here.
Okay, tell me what that is. What kind of data is those two things? Starts with a Q, both of them.
I forgot.
Oh gosh, Miss Oglesby, you're such a disappointment.
Quantitative data.
Qualitative.
Oh.
Who said that? I got to give you accolades for that. Miss Stewart, was that you?
I said qualitative.
Thank you, Miss Stewart. I appreciate you interacting this morning. I believe Mr. Chadman said something also.
Yeah, I said qualitative. I mean,
good job. And I'm going to keep y'all in the class, but Miss Oglesby, I'm sorry, we're going to have to get rid of you. So
That's
I'm
okay.
sorry. I will send you a drop slip. Qualitative, meaning what? Categories. So on the right-hand side, these are called categories. Blonde, brunettes, and redheads. I'm trying to get my cursor back over to the right. Okay. These right here are called categories. Distribution. And on the left, on the right-hand side, of course, y'all all know, unless you're non-sentient, if that's qualitative data, then this is what?
Quantitative.
That's called a Q. Like QUE. I'm queuing the class for the answer. Quantitative. Do y'all just not like me? Is that what it is? I mean, I could go out and put smokestacks on my truck. I could get them installed. Or what is it now? It's not smokestacks anymore. What is it now? My son says it's yee-yee, something yee-yee. Quantitative. What?
Squatter trots. That's a yee stuff now. It's a squatter trots.
Oh my gosh, that is the dumbest thing I think I've ever seen. Don't even get me started on that. Oh my gosh. You know, we used to make fun of smokestacks. Oh my gosh. I get started on that, I can't stop, so I better just shut up. All right, quantitative and qualitative. Quantitative, what are the left-hand side? What's the left-hand side? What is the left-hand side going to be called? It's not categories. Think of wrestling matches, boxing matches, and martial arts matches. Say again?
Is it a class?
Good job. They are called classes. Good job, Mr. Adams. I'm going to keep you in the class for a while. There you go.
Appreciate it.
Yeah, you're welcome. Just so long as you don't drive a squatted truck, you're okay. All right, so these are 2 test questions that will be on my test and standardized test. And a quantitative. Which one can you do mathematically? Which one can you find the mean, the standard deviation of?
Quantitative data.
Good job. What's the average of blondes, brunettes, and redheads? You can't do that. But you can find the mean age. Now, we're not going to do that in here because just the formula for doing that would scare some people, make them drop slip. Okay, but we're not going to do that in here, but you can find the mean and the standard deviation of this quantitative frequency distribution. Can anybody tell me how to find the total for the frequency distribution? How to find the total? What do you do?
You add up all the frequencies.
It doesn't work very well. 25, 33. So N would be 33. Now, I'm going to try, well, I don't know if it's going to work or not, but I'm going to try to write with a, well, okay, I'll do this. I want you to be able to find certain things on a frequency distribution. I want you to be able to find the following items on a frequency distribution. Okay, we're not going to worry about typos. If you don't understand one of my typos, just ask. I'm not going to spend time going back and changing things, okay? Because I barely got. I told my department head today, I'm not having class on Monday and Tuesday at the Anderson campus until they get this fixed. So we might have class, I'm sorry, that's for my hybrid classes, but this is ridiculous. All right, I want you to be able to find the following items on a frequency distribution. Of course, I want you to find N. I want you to be able to find the class width. I want to, let me just go ahead and write that out because you're going to ask that just as soon as I stop writing. I want you to be able to find the class boundaries. And I want you to be able to find the class midpoints. Now, some of you know how to do that because you were in, I don't know. Well, I really don't know that because I don't know what they teach you in high school. That they teach you all of this. Somebody can tell me after we finish if they teach you all of this stuff. N is equal to the total of the frequencies. Okay, class width. Well, before we get to class width, does anybody know what these are called beside classes? Anybody? Does anybody know what the left-hand side is called? Okay, I'm giving y'all ample chances. The left-hand side of the left side, that don't sound good. The left-hand side of your frequencies, the 20, the 25, the 30, and the 30. They're called your lower class limits. And the right-hand side, I'm going to let y'all figure that one out. 24, 29, 34, and 39. Can anybody with deductive reasoning tell me what those four numbers are called?
The upper class limits.
I tell you what, I can't do anything with y'all. Y'all are sharp. Limits. Now, why did I have to throw that in there? And we're going to put Hubert's going to put some abbreviations out here. LCL and the UCL. Now, and most of you are going to get those right. And the 5 or 6 is not going to do it my way. You're going to get them wrong. I always tell my students to make sure you go vertical. And that's not the way you spell vertical. I think that's the way you spell vertical. And that means subtract a lower class limit and corresponding, I'm going to say adjacent, if I can spell it right. Upper class limit. Somebody check me and see if I spelled that right. Upper class limit. Example. Parentheses, i.e. 25 minus 20, or minus. You could also do upper class limits. It doesn't matter. It doesn't matter which side. 29 minus 24. Or 34 minus 39. Somebody tell me what the what the class width of this frequency distribution is. Oh, that's supposed to be a 29. 5, yes ma'am, 5. Make sure I got all those right, 5. Now, why should you not go horizontal? Because what's 24 minus 20? 4. And you'll get the answer wrong. Now, how do you go horizontal? You have to count on your fingers from 20 to 24, and you get 5. You have to go vertical, and that way you won't ever have to worry about it. Class boundaries. If you are given whole numbers, you're going to go to the 10th. If you are given tenths, you go to the 100th. And so on. I'm going to put a parenthesis here, 0.95. And I'm going to put a parenthesis right here and put 0.5. So my class boundary for the first class is 19.5. $19.5 plus 5. 24.5, Hubert. Plus 5, 29.5. Plus 5, 34.5. Plus 5, 39.5. And how far? That's it. Those are your class boundaries. Now, since I was given whole numbers, 20 and 24 are whole numbers, All these are whole numbers. If you do whole numbers, you go to 0.5, a tenth. And you always use 0.5. If you're given tenths, if this was 20.1, then you would go to the hundredth, and these would be 0.95, 19.95, 24.95. And if you were given hundredths, you would go to the thousandth, and it would be 19.995 or 955, whichever you want to choose. But most people use 99. If you need to. Class midpoint, you find your first one, and that is a lower class limit plus upper class limit divided by 2. It's the average of your two lower class limit added to your upper class limit divided by 2. So therefore, 20 plus 24 divided by 2 is equal to, well, that's what, 44? And that would be 22. And then add your class width, 27. 27 plus 5 is what, 32? 37, 42. Well, you don't have to go further. I want you to be able to find. Now, which one is the one that you use in calculations? The midpoints. The midpoint is what you use in a calculation because you can't do 20 to 24 in a calculation. So therefore, you use the midpoint and the frequency to find calculations in the future. All right, somebody tell me if you got a question. Okay, let's go back to the handy dandy slide. And the first column is categories for a qualitative frequency distribution. And of course, the right-hand side is called frequency, which is the head count. Percentage. Write that down. You don't need to write all this down. You just need to write relative frequency equals percentage. Your frequency, and put relative frequency or percentage is equal to frequency divided by n. Somebody answer that phone. I'm supposed to go into a cardiac arrest right now.
I think I went harder than you last night.
What?
But I remember more than you.
What do you remember?
I threw up and you were on the phone and I was freaking out.
Hey, your mic's on.
Because it was red.
Okay. All right. Interesting.
It could have been dangerous.
It still doesn't beat the boyfriend coming in and going off on the girlfriend. It still doesn't beat that. Put frequency over n. And if you want to multiply it by 100 to get the percentage, you can. This right here is a decimal. So if you wanted to, if you wanted to make it a percentage, you would multiply it by 100. Cumulative frequency, to this day, I still don't understand what it's used for. It's useless, but I'll show you how to do it. In fact, let's go to our slide, our whiteboard, and let's do the relative frequency for this one right here. And we'll call it relative frequency. God, y'all got drunk, getting drunk on Sunday night. I don't think I could do that unless it was a Super Bowl or something. And I don't even watch the NFL anymore. I haven't watched the NFL in 5 years. Okay, I'll just do a couple of them and then y'all can fill in the blanks. So this one is going to be 5 divided by 33, and that's going to equal, I have no idea, and I'm not going to ask y'all because y'all won't tell me, so y'all won't interact with me, so I'm just going to do it myself. 5 divided by 33, and that is 0.15. And multiply that by 100, and that will give you 15%. Okay, I'm not going to do the rest of them because it's too complicated until they fix this thing. Now, what about the last one, cumulative frequency? Now, I'm going to do that one for you because it don't make any sense. So, hold on a second. Yes, stuff. You're welcome. And this will be called the cumulative frequency. I could just be sorry and just show you the slides. Cumulative frequency. And that's going to be, you put your first number down, 5, and then you add the second number, 15, then you add the third number, 30, and then you add the fourth number, 33. The fourth number or the last number should match your end. Now, I have no earthly idea to this day, and I've had 4 years at Clemson and 2 years as masters and 22 hours beyond masters. And I still don't know what the cumulative frequency is. I don't know. Maybe one of y'all can find out. I need to Google it one day and say, what in the world do we use the cumulative frequency for? I think it's a check to make sure you add it up in correctly. That's what I think it is, but that's just me. All right. Y'all settle down, please. Miss Stewart, settle down. So that's the cumulative frequency. Miss Stewart, you used to talk to me. Why don't you interact with me anymore? Have I said something to offend you?
No, I'm Googling the question.
Oh, okay. Well, tell me what you find out, because I except for checking in, I have no idea what it's used for.
Okay, I'll let you know.
What does it say?
Let me see.
Okay. Just break in whenever. Qualitative data consists of values, categories. We already talked about this. Quantitative, and we're going to call that classes, but of course you could say measure. Okay, I didn't know that we called it bins. I thought they were called classes. To this day, I'm going to call it classes, and I'm not going to stop. I'm not going to call it a bin. I'm going to call it a class. You can call it what you want to. What'd you find out, Miss Stewart?
It says whenever you wish to find out the popularity of a certain type of data or the likelihood that a given event will fall within a certain frequency distribution, a cumulative frequency table can be most useful. Does that make sense?
Yeah. I still don't see the purpose of it. I think
neither.
they're talking about finding the mode, maybe. But I still don't understand it. When you want to find the modal, all you got to do is find the highest number. But anyway, I'm not going to go there. All right, you can write down these if you want to, but we've already wrote them down. Qualitative data, categories. Quantitative data is examples of, we've already covered this, but there's 2 examples of qualitative and quantitative. You can write those down with your other examples that I gave you a while back. Qualitative, that's name of shoes, which is very, very important to you, becoming a better person. And heights of students, that's quantitative. Next. Classify each of the following data. Okay, they're about to wear this out. Audience ratings of films on a scale from 1 to 5. That would be quantitative. Okay. I guess it would be qualitative. I don't like that example, because you could actually figure, you could figure the average of, no, I disagree with that. Because you could, if I told you to, let's see, what's a movie, a good movie? Let's say, I can't think of one right now. Gone with the Wind, okay? Let's say Gone with the Wind, or, an older movie, something that, well, somebody's gonna complain about it no matter what, but Gone with the Wind, and I told you to give me a 1 through a 5. And then, can I find the average score? Yes. I'd add 5 plus 4 plus 5 plus 3 plus 2 plus 1. Now, what about you putting a 5 or a 4 on a movie? Now that is subjective. I agree with that. But I don't agree with that second part. So we could agree to disagree on that one. I hope I don't put that on a test, because I wouldn't want that one on a test. Next. Okay, that's quantitative, because they're exams. That's quantitative. And they got them in classes. And there's the head count. Write that down as an example. You don't have to write all the numbers down, but this is a prime example of a frequency distribution. So now, somebody tell me what the class width is.
5.
The point of the first class is. Somebody take your calculator and add 95 plus 99 and divide it by 2.
$97.
Should be 97 point, is it 97? Okay. I thought it would be, yeah, you're right, 97, it's not a decimal. Okay, and then if you wanted to find your, I can tell you what the class boundary is for the first one. The class boundary is 94.5 and 99.5. So that's your class boundary. And they got it bass backwards. They got the lowest on the bottom, which you would never do. But anyway, that's a good example of a frequency distribution, relative frequency, and a cumulative frequency. Make sure y'all understand bar and pie charts. Now, I'm not going to sit here and on some of this stuff, I'm not going to embarrass or, insult your intelligence. Most of y'all should be able, in 12 years of college, 12 years of school, you should be able to read a bar and pie graph. So we're just going to go through this, and if you want to go back and draw the stuff out, go back to the video. That way you can pause it, but I'm not going to spend a lot of time on this because all of you should know how to do this. All right? First of all, here is a test question. This one right here is a test question. How many people are in the class? Or how many grades are you counting? Take a minute and tell me how many grades there are by looking at this bar graph.
5.
7 right here. 4 and 7 is 11. And 11 plus 9 is 20. And 23 and 25. Now I know that the frequency distribution is right here for that. I know that. But there is a test question on the test that doesn't give you this, and they want you to look and add up these bars to get in. So make sure. Does anybody know the difference between a histogram and a bar chart? This is a joke, but it's not a joke, but it's a joke that they even worried about it. Can anybody tell me? Exactly. So if you take these bars and you squish them side by side, you would have a histogram. I always thought that statistics was developed by some do is they decided, well, I'm going to start my own mathematics up, and it's going to be called statistics, and I'm going to take things and I'm going to make them more complicated. So I'm going to take a bar chart and I'm going to call it something else, and I'm going to call it a histogram. And the only difference is my bars are going to touch each other. Because all throughout statistics, you find little things like that you're going, well, what the heck is the reason for this? And a histogram is one of those things. There's no reason for it other than just putting your bars together. It's really a joke. Make sure you can read. What is the number one thing on a pie chart? All the percentages must equal what?
100.
100. That will be a test question on a standardized test. This one too, not equal 100, but again, this question on a standardized test. This is a test question on a standardized test, and they'll change this to 56%. And they'll ask you, what is wrong with this pie chart? Is this pie chart valid or something like that? And you would say no. If this is 56%, you would say no because it'd be more than 100%. It has to equal 100. Has to. And I hope it does. Let's see. 36 and 28, that'd be what? 64? 64 plus that is 70 or 80. 64 would be 80, 88, and 12 is 100. So make sure you can do those two because that's all I'm going to ask you. Make sure when you do a graph, you make sure you title it, label it, and do a legend. I'm not going to get into that. Most of you were in biology lab. Were you do that in biology? Somebody? Okay. Thank you for the interaction. Vertical scale and title. Horizontal scale and title. I just told you that. Make sure you label it. Make sure you have a title, and make sure you have a legend. Again, this is stuff that you should have learned in your high school science classes, if not your high school math classes. I remember distinctively in my biology class, my teacher at Westside, he would go crazy. He would mark off if you didn't include these. Anybody got a biology teacher like that? Miss Stewart, I'll talk to you. Where did you learn about doing labels for graphs? Where did you learn?
Probably in high school, but that was so long ago. I just had to do them last semester in biology, though.
Biology teachers are crazy about this, okay? I can tell you that from experience. There's the histogram. Here's a histogram. Okay, they don't. Okay, now tell me what the difference in a bar chart is. Is a bar graph for quantitative data categories. The bars have a natural order and the bar widths have a specific meaning. Okay. A line chart is a bar chart without the lines. Now I understand having a line chart because some people like to see the line versus the boxes. I understand that. In fact, a lot of times I use a line chart when I'm doing a presentation. I will use a line chart over a bar chart. And I don't use a histogram because to me these are stupid. Chart or histogram in which the horizontal axis, okay, represents time. I'm not going to test you on that. I will test you on a line chart though. Let me see what time it is before y'all, okay, I'm going to shut her down. Anybody got a question? All right, let's see how far we are to the end. 12, okay, we're about halfway through. Ms. Stewart, please put a note that we are on slide number 12 on 5.5A or 5C? 5C, wasn't it?
Yeah, 5C.
Yeah. See, look at the top, it's got 5A. Now, why does it have 5A? I don't know what's going on with this computer. All right, let me shut off the presentation. And I'm going to shut off the recording. And I'm going to call up the handy dandy UTC. Have y'all seen it? Yeah, Hubert, we've seen it. We logged on this morning. Good. And I'm trying to figure it out. Where would, I guess it would be under ETC. Yep. Faculty. Stop recording.